Hello viewers, in this our virtual class, we're going to look at some questions in logarithm and attempt them. So the first one before us on the board is log a to base a plus log a log square root of a to base a. Here what we need to do here is we can attempt it in this way, because since the bases are the same, this become log base a, this is a, the bases are the same, and there is multiplication sign, this become times a times root a. Okay, then if you look at this carefully, log to base a, this is raised to power 1, this become a raised to power 1 times the square root of a means a raised to power half. And here the next thing is, this is indices. We can operate this with the laws of indices. Okay, the bases are the same and multiplication sign is here. All we need to do, we take the base as 1 and add the powers and do what? The power. So here become log to base a, then a raised to power 1 plus half. 1 plus half is 3 over 2, and this become log a raised to power 3 over 2. Half plus 1 is 3 over 2. So all we need to do, bring this back, and this become 3 over 2 log log a, and log a is equivalent to 1. So our answer here become 3 over 2 times 1. So our answer here is 3 over 2. Okay, the second question is, say, evaluate log 4 plus log 25. Log 4 plus log 25. Observe here, the first thing you have to look at for is the base. In this case, the bases are the same, and the next thing to do is to bring the log outside and look at the operation sign here. This is addition, becomes multiplication from the law of indices. Here this becomes log 100, and we know 100 we can express it as 10 raised to power 2, and this become this implies log 10 square, and log 10 square can be written as 2 from power 2 log 10. We know log 10 is 1, so that our answer will become 2 times 1, and this become 2. So log 4 plus log 25 is equivalent to 2. Okay, then the next question is this, question 3. See, evaluate log 100 minus log square root of 10. Square root of 10. Here we check the base first. The bases are the same, and here this is 100, this is root 10, and the sign here is minus. And in logarithm, minus means division. So you write express the base, the log first, and here we say this is 100 divided by the square root of 10. Recall this 100 here can be written as 10 raised to power 2 divide this is root 10 can be written as 10 raised to power half. Here you apply indices. Here we apply indices. Since the bases are the same and the operation sign here is division, all you need to do, you take the base as 1 and subtract the powers. So if you do this operation here, this is 2 times 4. 2 times 2 here will give us 4 minus 1. Okay, so 4 minus 1 is 3, and that means this log become log 10 raised to power 3 over 2. From this operation here, we have be able to do this operation here, and the result is 3 over 2. And applying law of indices, this power law, this become 3 over 2 log what? Log 10. And we know that log 10 is what? Log 10 is 1. Here, this one simply means that here what the base here is 10, but it's not written. So naturally, logarithm at base 10. Okay. Then let's look at the other question. Question 4. Question 4. See, evaluate log 2.7 base 3 plus log 10 base 3. Here we see that the base they are the same. The base are the same, but we need to look at this sign here. After finding out that the base are the same, the sign here is very, very important. So here, this is log base 3, open bracket. This is 2.7 times 10. And 2.7 times 10 simply means 27 over 10 times 10. This will go off with this, and what will be left here will become 27. So this becomes log 27 base 3. And this 27, we have a relationship with this 3. So we can, how many times do we need to raise 3 to give us 27? How many times do we need to raise 3 to give us 27? That's a simple definition. So here, this becomes log base 3, 3 raised to power what? 3. So we move this 3 back, and this becomes 3 log 3. I will know 3 log 3 is 1, and 3 times 1 is 3. So this the logarithm there is 3. Okay. Now let's look at this logarithm here, number 5. The number 5 question says, if we have a 5 raised to the power of log base 5, then here is 1 over 32 raised to the power of 1 over 5. Evaluate this logarithm. You recall from the law of logarithm, one of the laws is that if we have a, let's say a raised to the power of log x, and the base is also a, it means the result is just the quantity here. Okay, so we apply the same thing to this expression. So we have nothing to worry about this 5 raised to power log this. So what we are more concerned is this. So this becomes 1 over 32, all raised to power 1 over 5. And we recall that we can also express this 32 as 2 raised to power 5. So here we apply it here. This is 1 over 2 raised to power 5. We close the bracket times raised to the power of 1 over 5. Okay, we apply this in here. If we apply this 1 raised to the power 1 over 5, will also give us 1. That is the fifth root of 1 is 1. Then let's look at the fifth root of 32. Here it simply means 1 over 2 raised to the power 5 times 1 over 5. The power will affect everything in this bracket from the law of indices. So 5 will go with 5, and we'll be left with 1 over 2. So that is the answer to that question. Now let's look at number 6 question. Let's look at the next question here. The next question, look at it. The next question is 6. Question 6. Question 6. They say if they say evaluate, if I have a log to base look at this question, log to base b a raised to power n. Okay, evaluate this if b is equal to a raised to power 1 over n. Evaluate log a raised to the power n to base b if b is equal to a raised to the power 1 over n. Or what we need to do here, we first of all say let log a raised to the power n to base b, let it be something else. Let it, okay, we assume it is x. And from a definition of logarithm, here a raised to the power n will become b raised to the power x. So we are saying how many times are we going to raise this base so that it will give us a raised to the power n. Since we say let s is equal to log a raised to the power n to base b. So now we've expressed d, and we know that b, the expression for b is a raised to the power 1 over n. So we'll put in place of b, we'll put a raised to the power 1 over n. So here, in place of b here, we're going to put a raised to the power 1 over n. You know, and b is raised to the power what? Raised to the power x2. So this power here, the power inside 1 over n is going to multiply x, and that will give us x over n. So here we have becomes a raised to the power n is equal to what? X over a raised to the power x over n. A raised to the power x over n. A raised to the power x over n. And once we are here, look at the base here, they are the same. We have nothing to do with the base. All we need to do is to what? Is to compare the powers. So the powers here on the left hand side is n, and on the right hand side is x over what? N. And we know we are looking for x. So we multiply both sides by n. This will become n times n, so that x here will become n squared. So that this logarithm here, the value for it is n squared. Okay. Now let's look at the next question. The next question is simply a simultaneous equation. Logarithm is simultaneous. Say solve for x and y. Say we have a log x minus y to base 3 is equals 1. And the other question is I'll have a log 2x plus y or base 3 is equals to 2. Find x and y from these equations. Now let's look at this. You know, from the definition of logarithm, it simply means that we can say x minus y is equals to 3 raised to the power 1. So this base here will come and carry, we raise this one to the number of what we have here from definitions. The power to which the base must be raised, you know, to give this number. Okay, then this is our equation 1. Then from the second equation here, so here we can be written as 2x plus y is equals to 3 raised to the power of 2. So here this is x minus y from equation 1 is 1. Okay, and the other one is 2x plus y is equals to 3 raised to the power 2 is 9. Okay, this is equation 2. Okay, from here we can solve. This is a simultaneous equation with two unknown. Here we make use of elimination method. Look at the coefficient of x in equation 1 and that of equation 2. They are the same. This is coefficient of y here is 1, of y here is 1. But the sign here is minus and plus. Once the signs are different like that, what you need to do, since the coefficients are the same and the signs are different, what you need to do is to add. You add this. So s plus 2x, x plus 2x, and that will give us 3x. Minus y plus y, that will be off 1. Please, this is 3. Okay, 3 plus 9, that will give us what? Give us 12. So 3 raised by 1 is 3, not 1. Please, sorry for that mistake. All right. So the next thing is we divide both sides by 3. Divide both sides by 3, so that x will eventually become 4. So since we have obtained the value of x to be 4, we can obtain the value of y by putting the value of x in either of the equation 1 or 2. Let's use equation 1. This is equation 1 is s minus y, and s is 4 minus y equals 3. What we need to do here, we move this y this way and bring 3 this way. This is plus, as it's coming this way become minus 3. This is minus, as it's going this way become plus, so that y is equals to 1. Okay, that is one question. Then let's look at another question. The other question we're going to look at is okay, I say evaluate log we look at the log 3 over 5 base 5 plus 3 log 15 over 2 minus log 81 over 8. See, evaluate this. All we need to do here, all of them, please, they are to base 5. This is to base 5. They are all to base 5. Okay, the first thing, we've seen that they are all in the same base. Since they are all in the same base, our work will become very easier. The next thing is, let's look at this sign here. This is addition, this is subtraction. So we know how to the operation there. The next thing, we have to look at this carefully. And we need to, in this case, this 3 log base 5 15 over 2, we need to apply this law. This law n log base bx, which is the same thing as s raised by n log, which is the same thing as log s raised by n to base p. So we need to apply it here, so that we carry this one forward, and this become, let's do this first, log 3 over 5 to base 5 plus log base 5, this becomes 15 over 2 raised by 3 minus log 81 over 8 base 5. So we must express this. You must bring whatever variable or constant that is here and express this in form of power. So the next thing is, they are all in the same base, so this becomes log base 5 open bracket. So we need to apply the rules of logarithm here. When we see addition, we say it's multiplication 3 over 5. This sign here we change to multiplication. This becomes 15 raised by 3, which is 15 times 15 times 15. These 2 here, 2 times 2 times 2. This is division sign. This is subtraction sign, become division. So here this become 81 over 8. So we close our bracket. So we can do our normal cancellation here. 5 here 1, 5 here will give us 3. Okay. Oh, we still need to go further by inverting this division sign here first. So this is 3 over 5 times 15 times 15 times 15. This one is just give us 8. You know, here this sign has to be changed from our basic operation, and this will become times 8. Once you change this one to multiplication, we invert this fraction. Instead of becoming 81 over 8, it become 8 over 81. So here, this can just go with this. 5 here 1, 5 here is 3, 5 in 5 is 1, 5 in 15 is 3, 3 times 3 is 9, 9 in 81 is 9. So 3 here is 3, 3 in 15 is 5, 3 here is 1, 3 in 15 is what? 5. So we can see clearly that everything is left with 5 times 5. So here, let's write it clearly here. This is become log base 5. This 5 times 5 means 5 square, and you know, you apply the law of exponent here, and this become 2 log 5 5, and 2 log 5 5 is equal, 2 log 5 5 is equal to 2 times 1, and this become 2. So therefore the logarithm given below here is equivalent to 2 after all the proper simplifications. So the procedure for logarithms, first thing you must understand the laws, how they operate. So the laws are the basis or the foundation for the proper operation of a logarithm. So all you need to do, ensure that you follow the law, the rules or the laws tentatively. Once you do this, your answer is right. All you need to do, help me subscribe on my YouTube channel, and also hit the notification button. Have a nice time. See you in my next partial class.